Okay, what you're viewing here is a real-time clock with LED display based on a Raspberry Pi. Oh, okay, so it's a clock. Well, it is a real-time clock. Let's just point out what's here. Here's the Raspberry Pi, of course. There's the hub. This is a DS1307 clock module. And of course, I have an 8-digit LED display based on the MAX7219 LED display driver. This is totally written in Python. It's an evolution up from basic serial registers. And what we're going to be covering in the software in this is exactly how to use and program the MAX7219 to get what you're seeing here. Some neat tricks to use Python and how to tap into with Python the PC's real-time clock. In this case, I generally set up my Raspberry Pi as a low-end personal computer. I have material on how to set that up on other parts of my website, but here we're going to concentrate on the clock and serial protocols for the MAX7219. Let's go ahead and look at the software.
Illustrated here is the internal block diagram on the MAX7219 display driver. It really has three inputs: a load, which they call CS0, data in, and clock. This programs exactly the same way as a 74HC595. It consists of a 16-bit register, which I look at as two 8-bit registers, and program it as such. The software is virtually the same as the 74160s that I've used in my other videos. Once you clock in your 16 bits, of which half of it is address and then the other half is data, you will take CS low and it will shift all of the data in parallel into the appropriate registers and output drivers. Let's go down just a little bit more. Here is another illustration of the device. It shows the external, these are common cathode displays. It handles all the multiplexing for you, and the intensity is set by a single resistor. Here's your three inputs. Let's take a look at how I would program this thing now in Python. Alright, let's begin our tour of the actual programming itself. Of course, this is a Python program which is being run on the Raspberry Pi under Python. You can do it from the command line. I usually use Gainy, or you can use it under idle, that most people seem to like to use. Nonetheless, when you write any Python program, you really need this line up here, the exclamation point /user bin environment Python. The rest of this is simply comments. The file name, my website, my name, and so forth. And what this is really about. I'm going to output a time from the system clock. And you need to note, okay, to access GPIO pins, you have to operate under root. Now we begin our actual programming. I'm going to import the library rpi.gpio as GPIO. That saves me from having to put rpi dot every time I use GPIO. But for this, we're going to import the library time. Now, you've used time before as delays, but time can also be used to input the system's Linux clock, which I showed is tied into a DS1307 that I keep tied in as a real-time background clock on my Pi. You don't necessarily need that. If you're tied up to a server and the correct time is in there, it will pull it up. As far as the pin designations go, I'm going to use GPIO 11 for the latch, 12 for the clock and 7 for my data bit. And I have just made these equivalent, as you see here, to make the programming a little more clear as we go through it. Now it's time to set up our actual hardware pins. Starting over here, it's gpio.setup, and you can read this for yourself in the main schematic. All three have been set up as outputs, and initially I have set them all, particularly in this case, latch, which is 11 here. Yes, latch, I forgot to write latch back in on that, but it doesn't make a difference. I set both outputs to 0 or low. Now these next two subroutines that I define as pulse clock and pulse CS, which is your latch, simply means when I call these, it will take the output high and then take it low. It just creates a positive going clock pulse. In this case, this pulse clock is used to clock in the serial data, and pulse CS is used to latch the data into the control registers, which will give you your output. Alright, here is my primary shift out data routine that I call serial shift register out, SSR out. Whatever 8-bit value I send to this will be shifted out into the MAX7219. It's the same one that I use for a 74HC595 or 74HC160. Same identical program. What am I doing? This is 8-bit data, so I'm using a Python for loop, and I'm going to take the input value and I'm going to AND it with a hexadecimal 0x80. This is a bitwise AND. It's used to mask out all the other bits except the most significant bit, which is bit 7. If you remember your binary, from right to left, it is bit 0 through bit 7. I'm going to do a conditional test. I'm only can have temp can only come out to be two outcomes, 0 or 0x80. If it's equivalent, don't use equals, use your double equals here. If it's equivalent to 0x80, I want my data bit, which we define further up, to be set high. But if it's not else, I want it to set low. Then I'm going to call the subroutine we looked at earlier, called pulse the clock. Then I'm going to take the value and shift it 1 bit left. That way, when I go back and repeat the loop for the second go around, it will check that bit and keep repeating the process 8 times, and when done, it will simply, I put return. That just terminates the Python subroutine. Now we come to one of the most important and perhaps for some the most confusing properties in the MAX7219 is how do I get it set up to work initially? Alright, let's look at this routine I call init max or initialize MAX7219. First of all, at address 09, I have a choice of no decode or 4-bit BCD code. Okay, what that simply means, if I'm going to, I would use no decode if I wanted to use one of those arrows or graphic type things. But if I want to display numbers in binary coded decimal, I can select the BCD code. This would keep me from having to remember a long set of LED segment codes for each digit, which would make a real mess. So just for using numbers, you can use the BCD mode, which is what I use here. So the first what I do first is send out the address, which is 0x9. Then I send out the command, which happens to be code 0xFF. I pulse the latch, and I'm done. The next thing, and you can look at this in the spec sheet, you can set the intensity. That is at address 0xa, and I set it for 4. You have, there's a chart there. You can, the higher this number, the brighter the display. I put it on medium display. That can be found in the spec sheet. And it gives you a display rate. If you're looking at it from a 0 to 100, this is 9/30 seconds, which I suppose is about a little over a fourth of maximum brightness. Again, address, command, pulse the clock, pulse latch. The next thing I have to do is I have to select the number of digits that I want displayed. In this case, I programmed it for 7 digits. The address, of course, is 0x0b, and I selected 7. Now, this is a bit of a confusion here. When you're selecting how many digits you really want to use, and in this case, I wanted all 8. I wanted all 8 of my digits. If I really want to see, in the case of this clock, I needed all 8 digits. I used 7. 0 through 7 is 8. So the count in this always starts at 0. What is confusing is when you write to the registers to actually display, it starts at 1. I'll show you that a little later on. But in this case, it's address 0x0b, and for 8 digits, I have to send in 0x07, pulse the latch, done. Now, we come to this part. We actually have to turn the display on. You can turn the display on or off with a single command. So if I go to address 0x0c and I set it for 01, the display will come on. Or if I send 00 to that same address, latch it, the display will go off. So I have a convenient way to cut the display on and off under hardware control. Finally, this little for loop down here does nothing, and you notice it does nothing except put zeros in the display where it's set up. This is just an initiation thing, but this tells you if you don't put something there, it could come up garbage. So that's my initialization and setup routine. Alright, let's look at some more little subroutines. This is something I would really, if you were my student in my class, to get used to. I want you to write small, debugged subroutines as opposed to a big conglomerated mess you can never figure out if something goes wrong. So this little routine, write MAX7219, you will send in 2 items. You will send in the data to be written. That's going to end up being displayed or control command or whatever it is. And then you're going to go to location. And guess what? This just uses the SSR out, and then it pulses the latch and returns. That's all it does. The next 2 little commands are handy. They were based on the initialization setup business. It's just a command, display off, turns it off, or display on. There's nothing to send to them. They don't return anything. Okay, now we come to our main program. I will begin by initializing the device. I knit MAX7219. It will set up my registers. It will turn it on. Now I'm going to use a function called time.stringFileTime. And you'll see the format here. There's a percent capital H, colon, percent capital M, and then a colon and a percent capital S. If I was to string1 equals the time.stringFileTime in that format, and then I was to print string file 1, it would produce, if it was 10:05 and 31 seconds, an 8-bit string that you see here. This is an 8-bit string. Now, if you know anything about arrays, strings are simply arrays. They are a sequence of characters with an index. As you remember, you're going to use square brackets for index, so string index 0 equals 2, string index 1 equals 2, that's this 2 and that 2, string index 2 is colon, it's this one, and you go all the way down to string index 7 equals 1, that would be the one that you see out here. This is handy. In fact, if you wanted to put print string 1 0, it would print the 2 for you. Now, this is going to create some interesting programming to try to display on the MAX7219, and we will look at it in a minute. As I said, this is a string of a length of 8, which is numbered 0 through 7. You could even use this command, say another string, string 2, time.stringFileTime, and using the %d, %m, and %y, you can do the year. Remember, if you're using your Linux and you look at the clock, that's how they access the clock. Alright, let's see how we can finish this up with the main routine. Alright, here is my actual routine now that will write the time to the MAX7219 that you saw in the video. I'm going to use a Python for loop with an x in a range of 1 to 9. X is the digit position for the MAX7219, so I'm going to use it as the digit position for my MAX7219, but I'm going to have a separate variable that I'm going to define, it's an integer variable that I'm going to initialize as 7, and that's going to be used as the string pointer. So what are we doing? Alright, let's begin our loop here. The first thing I'm going to do is check, and remember this is my y is my string pointer from 0 through 8 to pick out my characters. If string index y is equal to colon, I want this to happen. I'm going to output a dash that you saw in the video and the clock. I want a dash and not a digit to separate minutes and hours. And so I'm going to write the code for the dash is 10, and I'm going to write it at position X. In the case of the first iteration, it will skip this anyway because it will come up as a regular number. If a colon does come up, this is what I want it to output. And it will, nonetheless, it will decrement the y by 1, and then it will immediately jump back up here. That's when you use continue, that it skips the rest of it down here and loops back from the beginning there as opposed to down here. Now, 6 of the 8 times this is going to be ignored because they're going to be regular non-colon characters. So what we're going to do is this will be skipped except for the 2 colons. Normally we're going to drop down here, and the idea now, we have to convert a character to an integer. To use the clock code, the numbers in the MAX7219, I have to have a binary coded decimal number of 0 to 9. Nonetheless, we're going to write whatever value integer we're going to change to an integer. So let's say, back up again before, that we had 22. It was 10 o'clock. Say it's going to come up at 2. The command integer, if you use string 1 y, and if it returns a 2, the thing integer will change it to an integer 2, and that's the number that I want to send up. X is my position in the 8-digit display. And when it does that, it will decrement y by 1. Then it will go ahead and do this here. This will be done 8 times through the loop to display the full 8 characters on the display. Then it will read the time again, and while this is all sitting in a while loop, it will go on and on forever. So my clock will work forever as long as I have the power on. Again, I'm going to use X as a position counter and Y as my string pointer. Pointer means very simply it's going to point to this here, or there, depending on the value of Y. That's what I mean by string pointer. And of course, it will never accomplish any of this down here because I just left it down there for another program, because it will never exit the while loop unless I put something in there, such as detecting a switch or when a certain time is met. And you can do this. Like if string 1 equals, you could put it in quotes, a particular time, it will exit the loop. But I'll let you figure that out. So study the actual program on the website, and I'll include the stuff for the time.stringFileTime, and you can have a lot of fun with it. So I hope the video was useful, and thanks for watching.